All right, the purpose of this video is to figure out how to deal with groups of pins all at once. But first, it's probably a good idea to talk about what this digital hourglass project is supposed to do. So what's supposed to happen is it keeps track of time. 10 minutes at a time, it's supposed to do it for 1 hour. So after the first 10 minutes, this guy is supposed to light up. And then after another 10 minutes, this guy is supposed to light up. And after another 10 minutes, so 30 minutes now, this guy is supposed to be lit up. And then so on and so forth. So like 40 minutes, these four are all lit up. 50 minutes, these guys are all lit up. And 60 minutes, they're all lit up. Anytime after 60, they will continue to all be lit up. Unless someone shakes it. This guy right here is a tilt switch. I'd actually recommend you take that out and replace it with a push button. Tilt switch seems like a great idea. It kind of feels like it is an hourglass, like you tip it upside down, it resets. However, this is a breadboard with wires in it that can easily come out. So generally it's a bad idea to shake your kind of semi-delicate circuit. So I just replace that with a button. But anyway, when you shake it or press the button, if you replace it with a button, all of these guys are supposed to go out and it's supposed to start counting again from 0. So there are two instances where we got to deal with all the LEDs at once. One, when we want to set all these guys to outputs, and two, when we want to reset them all. So let's take a look at that. We're going to deal with them with for statements. So if we look through our code here, we see the first guy in setup. Too far. All right, so in setup right here, if you remember noticing before that the LEDs were connected to pins 2 through 7. All these yellow wires are connected to the LEDs, so those are pins 2 through 7. So right here, we've got a for statement. Now, the variable we make for a for statement x starts out at 2, the first pin we want to mess with, the first pin we want to set to an output. It goes until when x is 2, 3, 4, 5, 6, 7, and as soon as x equals 8, this condition will become false, and so it'll be true, and this loop will execute while x is 2, 3, 4, 5, 6, and 7. So exactly the pin numbers we want. And it goes up by 1 each time because we want all of those pins to be set to outputs. So first pass through loop, x starts as 2. We do pin mode 2 to an output. So now we've set 2 to be an output. Hit the end bracket. X gets incremented by 1. So now x is 3. It checks to see if 3 is less than 8, which it is. So it goes through it again and sets pin 3 to be an output. And then it increases to 4, checks to see that it's still less than 8, which it is, so it passes through the loop again and sets 4 to an output. Hits the end bracket, does this guy again. Now x is 5, it checks that 5 is less than 8, which it is, and so it executes the loop again and makes 5 an output. And goes through again until finally, x is 7, it checks that 7 is less than 8, which it is, it makes 7 to an output, hits this thing, so it increases x by 1, now x is 8, it checks to see that 8 is less than 8, which is not true, so instead of executing the loop again, it jumps to the next line. So we could totally have 6 pin modes. From a computer perspective, it's a similarly large thing to do, but for my eyes, at around 6, this is easier. And it's a great, for statements are amazing. If you continue with robotics or programming, you use them all the time. So may as well get used to them now. So a good way to set them all up without doing it in 6 lines, you're doing it in 2 really. One's just a bracket. And then we need it again when we want to reset them all. And the logic is exactly the same, except instead of pin mode now, we're doing digital write. So we've shaken the switch, When we shake the switch, it's either on or off, and so it's checking to see that the current switch state is different than the switch state last passed through loop. So if you shake it, we want to turn all the lights off, and so instead of doing 6 digital writes, we just have 1 in this for loop, and so it starts off with x equals 2, keeps going until x equals 8, so from 2 to 7, and sets all of them to low. And this is a common design pattern, so learn it, love it, live it. Hope you enjoyed the video. See you next time.